Hello, today we will talk about another method we can use to solve a system of linear equations. Remember, the word system means more than one, right? More than one equation. Now, let's also keep in mind that when we're solving a system of equations, what we're doing is we're finding that one coordinate point that is a solution to both. That means if the two lines intersect just at one point, we will find that we'll have one solution. If the two lines are parallel and never intersect, we'll have zero solutions. And if the two equations, the two lines happen to be exactly the same line, they intersect at an infinite number of places. So, that's what we're looking for when we solve systems of equations. So this method we're going to use today has to do with adding equations together. All right, we can add equations together, and the equation, the equality will still hold. But we want to be able to add two equations together so that one of the variables is eliminated. So we need one of the two variables. We need the coefficients to be the same sign, the same number, different sign. So here's an example. We have two equations here. Negative 5x minus 6y equals 8, 5x plus 2y equals 4. Notice that our x's here, they have the same number, but a different sign. So the first one is a negative 5x, the second one is 5x. So what I'm going to do is I'm going to add these equations together. And notice, for us to add equations together, they have to be in the same form. These are both in the same form of like ax plus by equals c. If they're not in the same form, we can't add them together. So let's see how this works. Negative 5x plus 5x is 0. We have just eliminated the x variable. Negative 6y plus 2y gives me a negative 4y. The equals is in the same position. 8 plus 4 equals 12. We have this equation now that only has one variable in it. So let's solve for the y. Y will equal negative 3. Now I can take this and I can put it into either one of these equations and find x. So I'll use the first one. Negative 5x minus 6y, which is negative 3, equals 8. Negative 5x plus 18 equals 8. Let's subtract 18 from both sides, right? Negative 5x equals negative 10. Divide by negative 5. X equals 2. So my solution should be 2, negative 3. Now I always like to go back to the equations and just double check that that works. Let's see, negative 10 plus 18, yep. 10 minus 6 equals 4. They work. All right, now on this side, we have another, let's go back. Another system of equations, more than one. All right, I want one of the variables to have the same number, different sign. All right, well, I don't quite have that yet, do I? Both of my x's have a positive 7. I need one of those x's to have a coefficient of negative 7. How do I do that? Well, can't I multiply that first equation through by negative 1? I can do anything to an equation as long as I do it to both sides. So I'm going to rewrite that first equation right here, multiplied through by negative 1. Negative 7x plus 2y equals negative 5. Now, I'm going to add these together. Okay? 7x minus 7x, I've just eliminated the x variable. Negative 3y plus 2y gives me a negative y. 4 plus a negative 5 gives me negative 1. Divide everything by negative 1. Y equals 1. Go back to either equation. I'll just head back to the first one. 7x minus 2y equals 5. 7x minus 2 equals 5. I'll add 2. 7x equals 7, x equals 1. So my answer should be 1, 1. Let's double check that. 7 minus 2 is 5. 7 minus 3 is 4. It works. So here I had to multiply through one of the equations by -1 simply to change signs. And then I ended up with the coefficients on one of the variable to be the same number, different signs. Let's look at another set of examples. Ooh, these are a little crazier. All right, let's look at this one here. We need one of these variables to have the same number, different sign. Well, I could attack either of these to eliminate, but I'm going to look at the 4x and the 6x. I could actually get both of those easily to be a 12x, couldn't I? It's kind of like finding a least common denominator. And I need one of them to be a -12x. So let's say I want the top x to be -12. I can multiply that whole equation by -3, can't I? And then the x in the second equation, I want it to be 12, so I'll multiply the whole thing by 2. So let's bring those down. The first equation looks like this. -12x minus 15y equals -15. The second equation now, right, looks like this. 12x plus 14y equals 14. All right, let's add those equations together. 12x, -12x plus 12x. We've just eliminated the x's. -15y plus 14y gives me -y. -15 plus 14 gives me -1. So y equals 1. Take it to either equation and solve. Put the y in and solve for x. So 4x, I'll just use the first one, plus 5 times 1 plus 5 equals 5. Subtract 5, 4x equals 0, x equals 0. My answer should be 0, 1. Let's check that. Oh, I'm just looking at it. It seems to make sense. 0 plus 5 equals 5. 0 plus 7 equals 7. Okay? Now let's try this second equation, the second set of equations. Well, I think I can do this. I'm going to go after the y's. Ooh, I just noticed something. These are not in the same form. We need to rewrite them in the same form. So first thing I'm going to do is say 7x plus y equals 10. 5x plus 2y equals 11. All right, now we can see what we need to do. Well, I have a 2y in the second equation. Why don't I get a -2y in the first equation by multiplying through by a -2? All right, so here's this equation will stay the same. I'll call that 1. And now the second equation becomes -14x minus 2y equals -20. So I just changed that into equation number 2. Let's add those together. 5x minus 14x, -9x. 2y minus 2y, that's eliminated, equals 11 minus 20, -9. Therefore, x equals 1. All right, I can take this back to either equation. I'll use the first. 7 times 1, 7 plus y equals 10. Y will equal 3. So my answer should be 1, 3. Let's double check that. 6 plus 5 is 11. Yeah, that works. All right. So I need, again, the key is, right, need one variable to have same number, different signs, right? And I do that by multiplying the equations through by some constant. Again, I can do anything to an equation that I want as long as I do it to both sides. Let's look at another example. All right, here again in number 9, these are not in the same form. I need to get them in the same form. So I'm actually going to take the first equation and bring the 2y over. Subtract this. I'll say x minus 2y equals 4. Here I'll subtract the 2x over. -2x plus y equals 8. All right. Let's see what we got. I will take the first equation here, and I'm going to multiply it by 2 so that I get a 2x. All right, so I have 2x minus 4y equals 8. Down here, this stays the same. All right, 2x minus 2x. I'm adding those equations. I've just eliminated that. Negative 4y plus y is negative 3y. 8 plus 8 equals 16. Did I do that right? Oops. This is a negative 8 here, isn't it? Let's not lose that. Right? That's negative 8. So 8 minus 8 is 0. Okay, y equals 0. Take that back into either equation. If I take it right back here and I put 0 in, I find that x equals 4. So my point would be 4, 0. Let's check in the second equation. 8, yeah, that seems to work. Okay? Now, let's say I have an equation. I'm going to not use these. I'm going to take some equations and show you what you might end up getting. What if I had an equation that looked like this? All right, here's my two equations. Here are my two equations. Well, I could go after the x or the y. I am going to multiply the top by a negative 2 because I'm going to try to get rid of the x's. So the first equation becomes negative 2x minus 2y equals negative 6. Second equation still stays the same. Now let's add them together. Negative 2x plus 2x, negative 2y plus 2y. So on this side, nothing's left. I have 0. And then negative 6 plus 6 equals 0. Uh-oh. Is this a true statement? Yes, 0 equals 0. If this is a true statement, that means there's an infinite number of solutions, and these are exactly the same line. So if you get a true statement, they are exactly the same line. If instead you get something that looks like this, which is not a true statement, that means no solution. Okay? Let me show you one of those. I'm going to go to the end and I'm going to write one for you. Let's say I have all right. Now, these are actually in the same form, aren't they? They are. So we can try one like this. Well, let's say I got a 1 in front of these y's. Why don't I multiply the second one through by negative 1 to change my sign? So the first one stays 1y equals 3x plus 7. Second one becomes negative 1y equals negative 3x plus 2. All right, we're going to add these together. Remember, the equals will stay in the same position. So let's see what we get. 1y minus y. There's nothing on that side, is there? On this side, we have 3x minus 3x. Well, that's really 0. And then we have 7 plus 2 is 5. I'm sorry, 7 plus 2 is 9. Well, look at this. Is 0 equal to 9? Well, no. This is false. That means these are parallel lines. So there are no solutions. Whoops, let's back up. Okay, I'm going to stop here. Try these. See if you can get the same answers, but notice the special cases. If all variables drop out, all variables zero out, right? If all variables are eliminated, if you get a true statement, something like 0 equals 0, then those are the same lines, and you have infinite number of solutions. If you get a false statement, something like this, then they are parallel lines, and you get no solutions. Thank you. Good luck.